second lightning, we'll have Sonia. Sonia is the DevOps engineer with us here at Source. She was before an SRE at 20, and she's going to talk to us about how we use Ignition and Matchbox under Kubernetes. If you remember what I've told you right at the beginning, we index all of the code in the world, so we have 1.4 petabytes of data, and that's Sonia's challenge on a daily basis.
So hi, as Margarita already said, I'm Sonia. I do DevOps here at Source, and as she already said this morning, we analyze all the source code that we find in public Git repositories. And as you can imagine, that's not a task for 2 or 3 servers. We also handle a data volume of more than 1 petabyte. So that makes the cloud like insanely expensive for us. So we've recently decided to move to bare metal and leave the cloud. And what I would like to talk to you about is precisely about how we are building our own cluster on premises. So let's see first what we want. We have dozens of servers, probably hundreds in the next future. So we don't have the time or the mood to treat them as pets. They must be like cattle for us. So we need them to self-provisioned in an automated way. And by the way, we've chosen CoreOS as our operating system because our applications run on Kubernetes, and CoreOS is very convenient for this. It's especially designed to run containers, and it's very lightweight. Apart from provisioning, we need some essential configuration for each server, like its IP address or its hostname. And also, servers have different roles inside our cluster. So some settings need to be customized according to those roles. So how do we get to this picture? The automated provisioning part, we've solved it with iPixie. There's not much to talk about that. And regarding the customization, we've tried the 2 existing tools in the CoreOS ecosystem, which are Cloud Init and Ignition. I'm going to talk a little bit about both and show you why we chose Ignition. So Cloud Init offers a very simple and nice way to specify configuration in a declarative way. It uses YAML, so it's very easy to version control. And it allows dynamic values, so that it can fetch from the cloud provider's metadata services. So it's more or less nice, but it's halfway between provisioning and config management. On one hand, it handles tasks as set up the network, but on the other hand, it does it once network D is already running. So what it does is override the network configuration, and it does it in every boot, because Cloud Init runs every time that the machine starts. So it also does another stuff like creating user accounts and network D units. But once again, it writes the network, the system D units. But when it writes those units, system D is already running. So this happens because it runs on user space. So it runs very late in the boot process. So it's just not very efficient. And that's why we tried Ignition. Also, we ended up having to do things like rebooting the machines twice in order to apply some changes. It just have some issues with some settings. So we tried Ignition, which is a tool that is shipped with CoreOS since more than a year now. It's a tool designed to address all the issues that Cloud Init has, and it's focused very much in provisioning. It runs only one in the very first boot of the machines, and it runs very early in the boot process. It runs in the init-ram-fs stage before the PID1 process starts, which of course is systemd. It can make more or less the same stuff that Cloud Init does, but it also can handle disks. And this is a very neat feature because it can create partitions and format them and even set up RAID arrays. And the things that Cloud Init already did, Ignition does them in a much more efficient way. It improves a lot, like the network config and the systemd units, because it writes the files before systemd starts. So when the system pivots to the real root file system, systemd has already all the information and all the dependencies, so it can then start the services in a concurrent way, if possible, and it just takes the system to the state that we want, like real fast. So this is how it happens in the boot process. When systemd starts, Ignition has already done its job, and then it just starts all the services, and it can parallelize some of them, as you can see. However, Cloud Init works in a much different way. When systemd starts Cloud Init, network D is already up. So Cloud Init has to put it down and put it up again, and probably the same with more services. And of course, this is all done in a serial manner, and there's no concurrency here. So this is pretty much why we are using Ignition. And to be honest, it has also some things that are not very pretty, but in my opinion, they are not deal breakers. So one of them is that it uses JSON. Well, they've got their reasons that we could argue, but at least you're not supposed to write JSON by hand, but in a more human-friendly format, which they used to call Fuse. But the thing is that you need to convert that YAML format to JSON, and they provide with a transpiler tool for that. But it's a bit confusing, especially if you are used to the Cloud Init format, because both of them use a very similar YAML scheme, but with some differences. The other thing is that JSON, the configuration for JSON is static, and it doesn't support variable expansion. But there's this kind of workaround that in the end, you always can leverage the systemd's support for environment variables. So you just would need to enable a service to fetch that metadata and populate the environment file for systemd. So anyway, we don't need that, because we are using Matchbox to help us build the Ignition files using specific values for each host. So what's Matchbox? It's a service, an HTTP one in our case, that can render different type of configuration. The ones that we are interested in, of course, are Ignition and network boot configuration, especially, apart from metadata. And for each of these different types of config, it offers different HTTP endpoints. So this is how it works. the input files for Matchbox must be stored keeping this structure. So we define groups that match to different profiles. And this is done by according to hardware attributes like the serial number of MAC addresses, things like that. And then the profiles include information regarding the kernel that is going to be booted and which arguments it needs. And also the profiles point to the ignition files, which are going to be written in this Fuse YAML scheme, although it could be also pure JSON. But the thing is that these templates are going to be able to have Go template elements. So Matchbox then will evaluate them using the metadata from the groups file or the parameters that it may have received in the HTTP request. So we are going to see this in a very, very simple example because there's no time for any more thing else, but we are going to provision one host and customize it with its host name. So this is our Matchbox server with its configuration files, and this is our server which is not provisioned yet. So when we boot this server, our DNS is going to point it to our Matchbox server as its network boot provider. So it's going to make a request to the iPXE endpoint, okay, and passing it the MAC address. So now Matchbox is going to look in its groups files, trying to look for one, and it finds it, and it does because in this file, which this would be more or less the content, okay, there is a selector, as you can see, that is a match with that MAC address. So it also points to one profile, which in this case is going to be master. So it then goes to that file master, and and in that file, you can see some information about the kernel, like what's the kernel image that it's going to download and which parameters it's going to pass to the kernel. So it returns this information to the host as an iPXE script, which would have more or less this aspect. And the host now is going to download the kernel image and the init-ramfs image. And since one of the arguments, is this one, it's going to know that this is the first boot. So since it's the first boot, it's going to execute Ignition. And another argument, it's the same. Another argument is the URL with the config that it's going to download the configuration for Ignition from there, okay? So now it's going to make another request for, I don't know what the hell is happening, sorry. And it's going to make another request for Matchbox, and this time it's for the Ignition endpoint, okay? Passing it again the MAC address, so the process is kind of duplicated in this case, and it's going to match again with a group, but this time it's going to pay attention to the metadata, which in our case is just the host name. And when it goes to the matching profile, this time it's going to check which Ignition template it's the one to use. So in that template, which is more or less this, okay, here we say, okay, create my user account, blah, blah, and create the hostname file with these contents. And the content in this case is this variable that it needs to take the value from the group's metadata, okay? So it now renders all the final JSON configuration and returns it to the host. And now the host can run Ignition and write that hostname file and pass the control to systemd, which will do whatever it has to. Sorry, again, this is the JSON, and you can see that the value is being substituted. Okay, and now, as I was saying, systemd will start whatever to set the hostname at last in our server. So within 1 minute, more or less, which is what it takes the booting up process, we've provisioned a host completely, and it's production ready. So this is pretty awesome, and I invite you to try it. So this is all I have. I don't think there's time for any questions now, so, but feel free to grab me if you want to discuss anything. Thank you very much.